And we hope that I can help you guys to get over that, to clarify, okay? If we understand the in and out, I hope that, that's what I try to give you, the different perspectives, okay? The consistencies, maybe you will see some simplicity and be very confident in what you will be doing in this class and the next ones. Anyway, without further ado, last week, well, not last week, yesterday, we talked about, the truncation of cosine and the consequential new function, okay, the consequential new function, and the domain and range for the new function, and also the inverse function to the new function cosine A. You can see that there's three functions here. A function are the same or not. It's not just by their names. It's by their specifics. Naturally, cosine domain and range is such, okay, which is determined by its definition. But the other function cosine, this function, it's not considered the same function because it's been modified. So these two are not new functions. So when in the future, as I said to yesterday, you should not be confused by these two. You never have to ask the question and say, oh, are you talking about the other domain? No, whenever we refer cosine, we always refer to this function. That's why this function usually doesn't show up. Okay, as I said yesterday, it's rarely used. It's hidden there, and but it's not completely hidden because you need to know its existence for reasons I will mention later. Okay, so so in this regard, just be aware. Okay, so we do need to know these aspects. Okay, so I'm going to put these on the top, okay, for today's class as to start with, and I'm going to go over with you with some questions. Yesterday I put some points on the graph, which we all should be able to do. Once you thoroughly understand these graph, right, and its implications and different aspects, you can see that you should have no problem doing those homework questions. If you do have questions, if you do have trouble doing those homework problems, that means you didn't really understand what we talked about in class. It's that simple. So whenever you have trouble understanding, how am I going to do the homework? Oh, I'm just a little confused by this. Well, you should listen to the lecture again, because all of those aspects I have addressed those aspects to prevent those mistakes, because those comments I made, okay, you can see we have just been working on the unit circle, right? We've been just working on the unit circle. Who doesn't know this unit circle? But on the other hand, why did we see all these mistakes in calculus classes? Because these unit circles or these curves were not thoroughly understood. That's why. If we thoroughly understand this, you would ace every question. I have in the handout. Okay, so let's try some. Okay, so for you to study, you need to go back and forth. Lecture, okay, we'll read a book, and then exercise. You have question on exercise, you come back. So this kind of back and forth study will ensure eventually every aspect is completely clear, which will come down to this table, which will come down to this unit circle, which will come down to this curve. Okay, when I ask student, can you draw the sine curve, cosine curve? Everybody can do it. Well, otherwise you should not be in this class. But all kinds of mistakes are made. What does that tell me? What does that tell me? That tells me you can graph the curve, but you didn't understand the curve. Okay, so that's my diagnosis. That's my diagnosis. Okay. So after yesterday's class, and I marked on these points. I want you guys to take your time to understand, to really understand the curve. What other perspective I wish you to understand? Okay, I'm going to insert another row. I'm going to insert another row here just to talk about that, okay, let me do this. Okay, so you guys take notes, keep taking notes. Okay, I'm going to insert one more thing. Okay, I'm going to insert one more thing. Okay, there's one more thing I want to remind you of, that a fundamental. Okay, of what function is. What kind of input it takes, what kind of output it takes. For cosine, okay, you've seen this many times. The input are angles. The output, ratio. Arccosine is still a function. It takes ratio. It takes the ratio. Okay, and this also indicative is about how you express, how to show your work. Okay, during my office hours, still have people, write function, write input in the wrong way. Okay, and the input is ratio, and the output is angle. And of course, the new function is the same thing. It's just been, and you always need to be aware of domain and range. Always. If you were not like that before, from this class and onward, you have to be always aware of domain and range. Every function mentioned, you immediately think of what's the domain, what's the range? Is it a function? Is it one-to-one? These concepts will immediately pop up in your head. Okay, and you need this. You very much need this. And in calculus class, you will have to be aware of other things. Does it have limit here? Does it have limit over there? Does it have limit at infinity? Is it continuous? Is it differentiable? And you have more things to be concerned with. But at this point, you have to. So this is what I'm training you guys to do. Okay, this is what I'm training you guys. I'm training you. See, I'm consistent on the theme. Am I? Okay. So let's take some questions from you. Okay, do you have any questions on the marking of these points? And then you need to commit yourself after class. You need to do it. You need to do it by yourself at your own time. And also make the point to read about the postings I put there. But if you feel that the posting is not enough, go find a textbook to read about it. Okay, we just have a concentrated information here with all aspects considered. We can afford to do this because you had learned this before. Okay. But anyway, without further ado, and do you guys have any other questions? Right, how to read the curve? These pictures, okay, they're not marked perfectly. I hope you guys can read it. Okay, so can you read all these red and the black and the line of symmetry? All these are indicative of domain range points, input, output. It's all about that. You see, input, output, input, output, input, output, input, output for these black points, for the red points. Okay, so your focus is input, output, right? So at the beginning of the semester, we talk about function. There's input, there's output. Throughout the semester, we will be focusing on this, solely this concept. Okay, which I think has not been focused enough. All right, but we were working on different rules, of course. Any questions? If you don't have any questions, I plan to get started on the on arctangent, tangent and arctangent. So these are three major functions I will go over in details with you in class, but these three functions are used very much. And all the other three functions are also used, but to just a little lesser extent. And the expectation for you is that once you understand all three functions, and you will be able to work with the other functions by yourself. But if you have any questions, of course, always bring that to me. Okay. And I know there's a study group. There's some study group in class, right? I highly encourage that. So you guys, after discussions, you have questions, and don't hesitate to reach out to me. Okay, don't hesitate to reach out to me, even though I didn't put myself in that discussion because I don't want to interrupt while you guys in discussion. But I will welcome any comments, any questions from that group or any groups. All right. So yesterday I give you homework. Are you guys aware of those homework? Okay. Yeah. So are you guys doing them? Okay, good. No questions so far? Okay. All right. So you will have a quiz number 7 available to you. Okay. So once again, the focus is ARD. The focus is still ARD, either from A to D or D to A, right? We have seen that, A to D, D to A. All right. So today we're going to work on tangent. We talked about tangent curve earlier, didn't we? Right? Tangent is a ratio. Tangent is a ratio. So let's go back to the definition and look at tangent. Unit circle again. You see unit circle again. There's so much treasure in this unit circle. Okay. So we'll find out if at the end of the semester, if we can find those 1,000 words. Okay. Tangent. If we go back to the definition, right? What is the definition? Positive angle, negative angle, reference angle definition, right? ARD. With ARD as our stage, what kind of ratio is tangent?
Y over X.
Y over X. And that definition solely determined and what the domain should be for tangent, right? So do we still know the domain for tangent?
It's like all real numbers except for multiples of pi over 2.
That's right. So we went over that. So I'm not going to do that again, but I want you guys to reflect on that. Okay. So tangent function. Do you think tangent function is a one-to-one function? So you see my question is, right, is a function, is it one-to-one?
No.
No. Why not? So this
Because,
time we should be doing better, right?
yep.
How can you counter that example? You see, I'm repeating the same theme over and over again. Okay. Question after question, one after another. We're thinking, we're digging in, we're digging in. Does everybody follow? Is everybody with us? Is everybody with us? Yes? Keep calm, carry on. Huh? That's my cup. Look at my cup, okay? Keep calm, thinking. I'm glad to see some faces, really. Okay, I'm glad to see some faces, especially when you're smiling. Okay, that makes me very happy. Thank you. All right. Happy to see you guys. Okay, happy to share this stuff with you. Okay, all right. With ARD as our stage, okay, we know tangent is not a one-to-one. And the question is, of course, you know where we're heading, right? How do we make it one-to-one? So I want you guys to graph the curve and reflecting on the meaning of the curve of tangent, okay? So I'm gonna do the same. Okay, I'm graphing the curve. But right now, I want you to make those statements to tell me why it is not a one-to-one. I want your example to be powerful, and your words, you just use the right words, use enough words, not too many words, concise, following the definition, quoting the definition. Okay, if you like, you can type your answer, or you can share your answer in any way. And of course, you know, I will critique it. I will critique what you do. And I cannot tell you enough how much I enjoy this interaction. Okay, I really appreciate everybody contribute. Okay, there's nothing personal here. Okay, we just want to get to the bottom of how to overcome this mathematics. Okay. If x1 equals to 3, x2 equals to -3, f of x1 equals to 0, f of x2 equals 0. Okay, thank you for your contribution, Aaron. So please allow me. Okay, so right now what we are discussing is why is tangent 1-to-1. Why? So comment number 1, if x1 equals to 3, you are referring to tangent. Is that right, Aaron? Okay, I just, I just take some liberty to change this to the notation we're more familiar with. Okay, so do you mean? Okay, so first let me look at the logic of your words. The logic of your words is correct. It's good. Okay, your logic is good. However, we need to check on some facts. Okay, the logic is you have indicated, you see, you have named some x1, x2. They're not the same, but the output are the same. So you got that logical part. Okay, that part is a good job. However, we need to do some fact check. We need to check on the facts you stated here. So the question is, because if we're talking about tangent function, of course, so that I'm going to ask you, what is your rule? Do you mean this function you're talking about is f of x equals to tangent x? Is that right, Aaron? Yes, okay, thank you. If that's the case, I need to verify the fact. Okay, I'm telling you how I'm grading your work. Okay, I'm really showing you how I will be grading your work. I check your logical structure, right? You did not use whenever, which is good. And the next one is for your choices of input, and they are in the domain. Okay, they're not odd number multiples of pi over 2. You're referring to tangent x, right? All these things I'm going to be checking, right? And now you claim that f of x1 equals 0 and f of x3 equals 0. So you're telling me, you're also telling everybody else, tangent 3 is 0. And tangent of -3 is also 0. Is that what you meant? And the next question is, if that's what you meant, are they true? Are they true? Or you're missing something? Okay. How about everybody else? Keep your contribution coming. Is tangent 3 equals 0, 3 radians? That can be easily verified, right? Can you verify for me? You can use your calculator. My question is, are these facts? Are these true? Your wording is used correctly, your input is chosen okay. And the next question is, are the facts presented true? So you have two statements here, right? These two statements, are they true or not? Is tangent 3 equals 0? Ah, it's exactly 0. No, that has to be exactly the same value. Okay. The other thing is you guys need to know is that all the math teachers you are going to see in four-year schools, including in El Camino College or any other colleges, all your math professors are obsessed with exact value. Please remember that. You want to get points from your professors, you better get it exact. Okay, just for academic reason, right? You want to get your degree. From this point on, until the day you wear your graduation gowns, you graduated with whatever degree you want. Whenever you take math, you math professors are very concerned. You know the exact value. We don't care about those approximation. If there is an exact value, we want to know it. Okay, of course, sometimes the exact value doesn't exist, like pi or e, but we will be using pi, or we will be using e. By this time, you should notice that all of these math professors you have encountered, most of them seem to be obsessed. They're possessed with that requirement. So close to 0 is not good enough. Okay, so now we check the other number. I'm sorry, Aaron, it's good to know right now, right? Isn't that good to know? They're not the same. So you're not going to get full credit for this statement because the two statements you made here are not true. They're actually opposite to each other. In fact, we should recognize that because tangent is an odd function. Okay, we haven't talked about even odd yet, but we will be addressing those issues. Okay, the input are opposite, the output are going to be opposite. Okay, now, so your examples are not right. Your examples are not right. Okay, so keep trying. Keep trying. Anybody else who wants to show your work? Okay, so this example is flawed. Okay, your statement has a very good structure, had a sound logic, but your statements here are flawed. Therefore, it will not make it. It will not make it. Another one. Come on, guys.
Tangent 0 and tangent pi.
Can you make that complete statement?
Do you want me to type it?
Type it. I think, yeah, typing it, make your words powerful. If x1 equals to pi, x2 equals to -2 pi. So let's look at this one.
Oh wait, not a negative, just regular 2 pi. I didn't see that.
Okay. So remove the negative sign, is that right? That make you happy?
Yes.
Okay, so let's examine these two. Okay, I usually don't like to write it 10 like this. By the way, I forgot to correct this one. You will write the function as you specified. However you defined it, however you defined it. Okay, if you use A, then you're going to use A. There's some kind of consistency. Even some of those symbols are just placeholders. You follow me? And here it seems that everybody likes to use X. I use A because I want to emphasize the input for tangent is angle. You guys follow me? Even though all the textbook using X, if you always know what that X is, it's an angle, that's fine. But I'm also making the point to remind you what kind of number is being regarded as when you put it as input. Okay, so chord length example is still very good structure. Okay, x1, so x1, x2 obviously are not the same. How about his statement? Are these two true? Are these two statements true? Are the statement true? Is tangent pi equals 0?
Yeah.
Tangent pi equals sine pi over cosine pi. Sine pi is 0, right? Correct. So this will be this will work. This will work because everything you can see, I would check everything. I would check everything. Your words, your statement. That's my job. It's my job. Okay. You actually could have many examples in this case. Okay. How do you get those examples? Right. So I'm not going to modify too much more. It's just it takes time. It takes time. Okay. When we use this curve, do we still understand this curve? I'm going to give you some more clues as to make up those examples, okay? To pick up those examples. There's so many examples. If you know how to use a curve, you understand input, output, and what's the implication, right? You can come up as many examples as you want. Okay, so do we understand this curve? For example, I'm going to ask you to mark some points. Okay, I'm going to mark this point right here. This point has a height of 1. Okay, and this point has the height of -1. Could you mark these 2 points for me? Yes, they are related to special values. Okay, mark those 2 points. Okay, I'm going to make a little adjustment to the picture. Good. Marking these 2 points. Okay, I'm going to make some adjustments, so that might make it easier for me to get feedback from you. Okay, so one I put a star, and the other one I put a heart, on the other one put a star. Okay, so on your, I wish to get some reply from you. Okay, you can write on paper, take a picture, upload, or you can also just type your answer on the chat. You can prompt your answer, but any way you want. I would like to have some interactions from you, response from you. Mark these 2 points. One is a heart and the other one is a star. Okay, so this way, and I'm telling you where it sits. It sits at the same level of 1 over here, and this one sits at the same level of -1. So this should remind you of some special angles. Okay, but I just want you to mark the points. And reflecting on the meaning. Reflecting on the meaning. Okay. I got some response. Did you guys see the response from Bailey on chat? What do you think of that? Or you have your own answers, I'm sure. What do you think? What do you think? Perfect answer. Very good job, Bailey. Okay, great job. So the heart, what is the heart? Right? Remember, this is tangent curve. Tangent curve is about tangent and tangent alone, right? Tangent curve is about tangent. So what is tangent? Tangent takes input and produces output. The input is the angle and the output is what? The output is a ratio. The ratio, of course, is y over x, right? So this point is pi over 4. That's the angle, and the ratio is a +1. And the star, okay, let me change the color. It's negative pi over 4, and the ratio is -1. What do they correspond to? Oh, this color is too light. Okay, what do they correspond to? Okay, pi, how long is pi? Pi over 4, sorry. Pi over 4. I'm going to use purple. Okay, what is pi over 4? This is the input, this is the output. Input, output, input, output. That doesn't change. It will never change. Do you guys follow me? It will never change. Ever since that rectangular system being introduced to us, maybe in elementary algebra, the nature x comma y, which is input comma output, never change. And it will never change. Okay, we can increase another dimension, x, y, z. You know, we can increase the dimension to, you know, as many as you want. Okay. All right. So this point, what is the measure of pi over 4? It's this much. Okay. This much is how much? This much is how much? Is this arc length. See, I was making that adjustment. I was making that adjustment so that I can make them look about the same length. Okay, Mikhail has a question. Mikhail has a question. I'll get to your question. Okay, I'll get to your question. Very good question. So you can see this arc length straighten up. How many times you have heard this? By this time is 3-4 times, so maybe 10 times already. This is the arc length. This arc length is the purple. The arc length on the unit circle measure from the standard position to pi over 4. That's a pi over 4. And what is the ratio? Where do we get the 1? We take the blue number divided by the red number. At this point, the blue number and the red number is the same. They're the same. So numerator divided by denominator, when they are the same, the ratio is exactly 1. Okay, we got a question. Okay, I need to get to this question, these questions. Excuse me. One question for Mikhail is that he asked, why isn't star 3 pi over 4? Why isn't star 3 pi over 4? And Kyle said, why wouldn't be 5 pi over 4? Why wouldn't it be pi over 4? 5 pi over 4. Yes, we do have 3 pi over 4 somewhere. So where is 3 pi over 4? Where would it be 3 pi over 4? Okay, so I'm gonna do some cleaning up. Where would it be 3 pi over 4?
Second quadrant.
Second quadrant. Where is the terminal? Right here, right?
Yep.
Yes. And what will be the arc length? This is the arc length, right? Yes. You follow me? So this is the arc length. This arc length stretch and straighten. Where would it be end up with? Well, you have to assess the value, right? 3 pi over 4, you get a numerical value. Pi over 4, you get a numerical value. That numerical value is going to be smaller than 1. 3 pi over 4, however, is going to be larger than 1. Do you follow me? You do assess those values, don't you? What is pi over 4? Pi is 3.14. 3.14 divided by 4 is less than 1. So that's why it's going to be here. But 3 pi over 4, however, is going to be way larger than 4, yes? And where would it end up? It's definitely over 4, over 1, I'm sorry. So you're going to measure that. So can you guys find out what is 3 pi over 4? Calculator. Use a calculator. 3 pi over 4.
-1.
Well, pi is 3.14. So 3 times 3.14 is 9. 9 more than 9. 9 divided by 4 is more than 2. So, and this is going to be greater than 2, less than 3. So your 3 pi over 4 will end up to be where? To be somewhere here. Okay. Approximately. So where would it be? I'm going to use a different color. Okay. I'm going to use a different color to do that measurement. Say green. Okay. 3 pi over 4, Mikhail. Okay. I think a 3 pi over 4 will end up to be somewhere over here. Okay. So that's a 3 pi over 4. You follow me? So this green is 3 pi over 4, approximately. So what will be the ratio? What will be the ratio? The ratio is here. Approximately, okay? It should be -1. You follow me? Hold on. I'm sorry, I meant this should be just a little bit longer. Okay, just a little bit longer. Okay. And this is 3 pi over 4. This is 3 pi, this is the ratio for 3 pi over 4, which should be what? -1. And this lens, I should make it purple. Okay, I apologize. I'm going to do it again. Okay. This lens, we're talking about 3 pi over 4, okay? We're talking about 3 pi over 4. 3 pi over 4, that's 3 pi over 4. Purple, the same lens as this arc lens. Do you get it? Okay, we get 2.35. Did you get it, Mikhail? Does that make sense? Mikhail? Okay, so let's get to Kyle's question. 5 pi over 4, right? Why wouldn't it be 5 pi over 4? Well, where's 5 pi over 4? So let's measure what's 5 pi over 4. Where's 5 pi over 4? 5 pi over 4 on the unit circle, where would it be?
The third quadrant.
All right, 5 pi over 4. Okay, so let's identify the terminal. Okay, the terminal is 5 pi over 4 right here. 5 pi over 4 is positive, right? So the angle is measured from standard position counterclockwise. So this is the terminal. And what would be the purple arc length measured from the same place? Right here. Do you follow me? Are you going to take this arc length? You're going to take this arc length, straighten it up. You straighten it up, what you get? Could anybody calculate for what's 5 pi over 4? 5 pi, 5 times 3, that's about more than 15. More than 15 divided by 4 is more than 3. Okay, so let's look at the new message. 3.92. Thank you, Kyle. 3.92. So this purple arc length is 3.92. Okay, 3.92. We straighten it. We make it straight. And we measure 3.92. That's close to 4 right here. Does that make sense? And that's the radiant arc length. Now, what is the ratio? The ratio is given right here. So can you mark this point? Can you mark this point? Can we mark this point? Can we mark this point? 5 pi over 4, comma,
1.
positive 1. Right? That's the ratio of the blue over the red, right?
Yep. Exactly.
You got it?
Yeah.
Is that nice?
Yeah,
How
very
does
nice.
it feel? How does it feel?
Feels great. It's super easy.
I know, it feels amazing, isn't it?
Yeah, I was expecting it to be a lot harder.
I'm so happy to hear that. You guys show me some smiling faces, please. Come on, guys, show me some smiling faces. I want to see you when you feel good. Come on. Come back, Mikhail. Bailey, who else? Come on, guys, where's everybody else? Come on, I just need some smiling faces. Is that too much to ask for? And you refuse me for that? You deny me that opportunity. Where's Mikhail? I see Bailey, I see Cortland. Where's everybody else? Come on, guys, I want to see some smiling faces that you get it. We all have those moments, we get it, right? I got it. It feels amazing, isn't it? Doesn't feel amazing. All right, so in this regard, we actually have many, many examples, right? So let's come back to the one-to-one function. Can you give me just one more example? One more example. Have you figured out how to get those examples so you can get as many as you want?
Yeah.
I wish to hear from you. Different input, same output. You know the examples are out there. That's right. Good answer, Aaron. Multiples of pi over 4. However, okay, 3 pi over 4, you end up with -1. That's right. Odd number, but do we need so many? We really don't need so many, right? We only need 2 pair. We only need 1 pair. 1 pair. Okay. What I'm trying to tell you, how do you find that 1 pair? Okay, all these answers are good. Aaron's answer is also good. Okay, because I'm sure he's thinking, okay, he knows how to figure out. I'm going to show you a systematic way to do it. Okay. How about, okay, you just draw a horizontal line arbitrarily. I'm not doing arbitrarily. I'm just drawing this horizontal line. Same output, right? Same output. Do I get same output here? This point and that point. Same output, guarantee, right? Do we get same output? Same output. Same output. Obviously different input, right? You just have to pick out these 2 inputs. Do you follow me? For the same reason, you can draw your horizontal line here. Right? That's what happens when you get the 0, 2 pi, -2 pi, and so on and so forth, right? And you can draw these horizontal line tests. You can draw this horizontal line and to identify the point of your desire. You only need 2. Okay? So we're gonna pass this, does everybody get it? All right, so let's move forward. It's not a one-to-one, so we're gonna create a one-to-one function. We're gonna create a one-to-one function. How do we create that one-to-one function? obviously we have a technique which is called truncation, right? Truncation. So how do we truncate? How do we truncate? Okay, so I'm gonna change the curve a little bit. Okay, just show more of it. There's so many pieces. How do we truncate so that we will get a one-to-one function? You cut it vertically, meet it, you touch the curve once. You touch it horizontally, you touch the curve only once. How should we cut it? Which piece do you want to say? Which piece will be the simplest? Which piece will be the simplest?
The middle,
Hmm?
the middle part.
That's right. That's right. Right? The simplest piece will be the one in the middle. Right? So how do we cut? How do we make a cut? Now, so let's do it carefully, right? We're gonna cut. I want you to cut on your paper. Okay, so please cut on your paper and then reflect how you would express, you would express it. We're gonna cut from here. Okay, where else are you gonna cut? Over there. Oh, wait. I need to modify that. Okay, it's a red dash. Okay, and this cut, we're gonna cut everything from here. Chop, chop, chop. Right? And the remaining function is what? 1-to-1. 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 So after that truncation, can we describe this function that's being left? Okay, everything else is cut off. Can we describe the function right here in the middle? I want everybody to describe this function. New function. For this new function, we need to describe the domain and range, right? That's really what the main description need to be there. There's a new function, we're going to use the same name, but it's really a new function. How do we make that distinction? New domain. If you look at the way we handle, if you look at the way we handle sine, cosine, now tangent. Similar, isn't it? Are they similar? The way we handle them are similar. It's just for different rules, we have a slightly different strategy. The methods are similar. The methods are similar. Okay, so here I use this notation. Okay, of course you can use interval, right? Of course you can use interval. The interval notation would be, okay, the interval notation comes last because I want to train you guys to be better at inequality. Okay, interval everybody can do. Inequality, not everybody can do it well. Okay, so I want to train you guys to do inequality well. It's immensely important for your success in math. Okay, so all these three forms, which ones are my favorites? You should know. Which ones? These are my favorites. This one is not so favorite. You got that? Okay. Now, sorry, I apologize to that interval notation. Okay, because you guys all know it. Okay, so now are we ready to create that inverse function? Are we ready? All right. So the new function, okay, so I'm going to clean this up a little bit. Okay, the new function, we're going to have a special name for it. Insert a column. Okay, and this is the inverse function for the new function, right? This is the inverse function of the new function. So we're going to call it, what are we going to call it? We're going to call it arctan. And we know arctan takes input. What kind of input does it take? Now, what will be the domain and range for arctan? What will be the domain and range for arctan?
Domain is all real numbers, and then the range is negative pi over 2 and pi over 2.
Perfect. You got it. Okay, you got it. How about everybody else? So arctan is always between negative pi over 2 to pi over 2. Once you go through this process, you're set. You're set. Okay?
Professor,
Yes.
for the range of arctangent, it's greater than or equal to sign, right? Because I think you put the greater than sign.
No equal. Greater than. Not a greater than or equal.
It's not?
It cannot equal. If you put equal there, you're gonna get 0. Sorry, Cortland. Good question.
Okay.
That should awaken everybody else. We talk about that the domain for 10, the multiples of pi over 2, they are gone. Did you guys notice I write the domain for tangent in a slightly different form? Did anyone notice? Do you think this will work? I did this on purpose. I don't know if you guys noted. 2k plus 1, 2k minus 1, it doesn't matter which one you use. Okay, they all produce odd numbers. Okay, but anyway, so you can see the inverse function to each other. One's domain is the other's range, right? One's domain is other's range. So let's look at the function mechanism. Let's look at the function mechanism, which I want to remind you of. I always want to remind you these basic things. The mechanism, tangent takes what? What kind of input?
Angle.
Takes angle. Okay, and what's output? Okay, how about this new function? Same thing, just being restricted. How about arctan? What kind of input does it take?
A ratio.
That's right, it takes ratio. And what comes out?
The angle.
That's the meaning of inverse. Okay, reversing the input and output. Okay, some people get confused but with inverse and reciprocal. They're totally different things. They're totally different animals. Okay, so now with all this said and done, do you have any questions so far? Because we're about to bring up the curve of arctangent. Arctangent will be used, many times in your calculus classes. Many times in your calculus class. So it's about time we bring it out, right? It's about time. Yeah. The red curve. And this red curve should be, there's asymptotes, right? So can you draw those asymptotes for me? I think my color coordination is a little bit, is this okay or should I change it? Okay, I'm going to change something. Okay, I'm going to change something. As you can see, I'm somewhat a perfectionist. I'm going to make it yellow. Okay, for tangent, I use yellow. And for the green, I'm going to turn them red. So now it's time for you to mark some points. And also, we need to look at the unit circle on the left. Okay, we need to look at the unit circle on the left. If the new function is defined as such, remember we also reflect on the unit circle, right? With that truncation takes place, what quadrant are left and what quadrant are discarded? Look at the new function, right? With the new function introduced, for the new function, which quadrant in the unit circle is left? Which quadrant in the unit circle are discarded?
3 and 4.
That's right. I'm not sure anymore. Wait, you said 3 and 4? Wait a minute, no. I wish you were right. Keep quadrant 4, 1 and 4, that's right. Quadrant 3 and quadrant 2 are gone for the new function. If you reflect on sine, cosine, tangent, right? Sine, cosine, tangent. So there does it bear a little similarity to sine or cosine? To sine, right? Because sine is from negative pi over to arcsine, you know, is the range is from negative pi over to the positive pi over 2, inclusive though. Okay, arcsine include a negative pi over 2 to positive pi over 2, but arctangent does not. It has to be less than or, you know, cannot be less than or equal. Do you guys notice that little details? Okay, the devil is in the detail. Okay, so if you reflect on this definition of the new function, do you guys see my cursor? It corresponds to only quadrant 1 and quadrant 2, and what is more, this entire line is also not included because that's not in the domain. Do you follow me? So they're red. They're forbidden. Okay, it's only from negative pi over 2 to positive pi over 2. You see, it's less than. Do you follow me? Do you guys see that? And for sine is less than or equal. Okay, there's some minor difference, and all these differences are decided by what? All these differences are decided at the moment of a definition. You don't need to look elsewhere. So now, let's work on the expressions. Okay, let's work on how do we identify points. Okay, so I'm going to select a few points. Okay, they're all related to special angle. Okay, because those I'm not going to ask you to identify a random point because I know it's hard to identify those points, right? It's not precise. It's not a precise sign. It's a concept. What is essential for me to identify the points is what's the nature of input, what's the nature of output. Input are angles or ratio or angle. That's at the heart of my question. Do you guys follow me? I don't care about your value is precise or not. But I want to know that you know what's the input, what's the nature of that input. Is it angle or ratio? Because after all, you only have angle or ratio to choose from, right? You don't have other choices. Yes? All right, so I'm gonna ask you to identify some points. I'm going to put a point here. You see, it's at the same height of 1. Wait, hold on. Never mind. Sorry about that. I'm going to ask you to identify this one. Mark this point, okay? And mark that point. And yeah, just mark these 2 points. Other points just a little bit difficult to identify. Okay, that's on the arctangent. Okay, and I'm going to identify 2 stars. The hearts are on the arctangent. The hearts, the stars are on tangent. Okay. And more.
So you want the heart function, what they are, the coordinates for the heart.
I want the hearts identified, but you can see the heart is on the tangent curve.
Yeah, so it'd be arc tan. What's it called? -1, and then right.
Okay, so give me the answer on chat or write it on your paper, take a picture to show me. Okay, and I want you to, I just told you what I want to see. I want you to know which one you can identify the input is angle or ratio for the different functions. That's the key. Okay. I apologize because I don't know, because I'm not clear enough about, so I need to make some numbers. Okay. I'm going to call this is heart number 1. And this is heart number 2. Okay, my bad. Okay, if I'm not being clear. Heart number 1, heart number 2, star number 1, star number 2, and star number 3. Is that clear? So now, Andy, you have to tell me your 1 comma pi over 4 is for what? Okay. Andy, you just need to clarify one thing for me. And Kevin has answers here. Kevin got answer 1, heart number 1, heart number 2, heart number 1, heart number 2. Okay. Heart number 1, he got the ratio right. He got 1 pi over 4. Heart number 2, the first number is ratio, the second number is angle. That is it's a good take because you did get the input should be ratio, the output is angle, but the second angle is wrong. Okay, the angle for number 2, that's right. Okay, Andy got it right. Yes. Okay, Kevin, your second one is, I want everybody to look at these answers. As I'm critiquing this, I'm criticized. I'm sorry, I don't want to use the word criticize. I'm a comment on your answers. Please don't take it personally. Be aware of the domain and range for arctangent. Okay, the domain and range for arctangent. I'm getting all these answers. I'm so pleased. I'm so pleased. Okay, Kevin, your second answer, 7 pi over 4, is outside the range of arctangent. Therefore, it is wrong. You got me?
Just be a negative, right? Instead of what's it
Has
called?
It's
Pi.
not about negative positive. It's about your answer has to be in the range of arctangent.
But instead of going around, it would have to just be a negative, right? So -pi over 4.
So your angle, yes, if it's negative ratio, it's going to be negative angle. So your angle is always going to be measured from the standard position. If it's a positive ratio, it's going to be in the first quadrant. The negative ratio is going to be the fourth quadrant. So the angle will be measured from the standard position clockwise.
Got it.
Clockwise. That's right. That's right. Okay. So let me look at the next comments. Okay. Kevin says, yes. I think he just tried to, I think that's the right answer. I think I understand what he meant is that he meant this, you know, just to put the two parentheses. That's a good effort. Okay. Star one, star two, star one, star two, star one. Perfect. Star two, perfect. Okay. And Andy contributed for star three. Star three is 5 pi over 4. Perfect. Wonderful. You guys got it. Could I make that declaration that you guys got it? Are you smiling?
Yes.
Could I see? Could I see?
Let
Are
me
you
see.
being shy?
Let me see.
All right, guys. So number one, you need to be aware of what is the input, the nature of the input, whether it's angle or ratio. Number two, all of our answers must be in the domain and the range of that specific function. That's why 7 pi over 4 for arctangent can never be true, because arctangent's range is between negative pi over 2 to positive pi over 2. You will never get that answer 7 pi over 4, not in a million years for arctangent. Got it? These are the rules that have been carved on the stone and implemented in every scientific calculation device. I'm not exaggerating. Okay, they are implemented even on the machinery sent to Pluto, to Mars. You know, all the machineries in the world, they have implemented these domain and range requirement. So when you look at this arctangent, so anybody has any questions before I move on to elaborate on the significance of domain and range? So far, so good? No questions? Okay. So I'm gonna, how about those other people? Because we only have we'll have several people always correspond to, but some people are staying silent. I don't want to leave you guys like, you know, unattended. Are you there?
I'm here.
Okay.
Yeah,
All right.
I'm here too.
Okay. What I was commenting on this domain and range for arctangent, and this domain and range on Arccosine and domain and range for Arcsine, they are implemented. They are implemented by programming in every devices, every scientific devices. You can't change them. Sorry. It's like if you want to change it, you're like David and Goliath. You're like David against Goliath, because that Goliath is humongous. My comparison may not be the best comparison, but I want you to visualize that this entire world is implemented in scientific fields by these rules. Do you follow me? Do you want to make such an effort to change it? It's not worth it, isn't it? Is it worth your effort? No. I mean, in David Goliath's case, it's kind of, you know, it's worth it. But in this case, it's not worth it. So don't change it, accept it. Yes? All right. If you want to be David, you want to be the David, you know, like the David in the scripture, but not the David to go against these rules. Okay, it's not worth it. I'll tell you, it's not worth it. Okay. All right. So that's how important it is. Okay, you will see the quiz today. Okay, I have cooked a quiz. All right, I've cooked the quiz. Any questions? And the one more perspective is that remember we work with these we work with the unit circle, right? For arctangent. For arctangent, right? We know that the truncation, all of that stuff, and we discard quadrant 2 and quadrant 3, and we don't use this vertical line, and you can see that it guarantees these pieces is 1-to-1. Okay, 1-to-1, and for every ratio, there's only one angle, vice versa. So these 1-to-1 function, arcsine, arccosine, arctangent, arccotangent, arcsecant, arccosecant, all of these functions, they are 1-to-1 function. And for each input they can take from their domain, the output has to be unique. The output has to be unique. Let me say one more time. Their output has to be unique, one and only. Okay, we have a couple minutes. I want to go over some examples for what I meant. Okay, I'm going to give you some examples. Over here. Okay, since tangent 3 pi over 4 is equals to -1. Thus, arctan of -1 is going to be equals to 3 pi over 4. What do you think? I want to tell you where this question come from. Okay, of course, this question, a lot of our students do this. But this question also has the honor to be put on an interview for math department when hiring new faculty. So if one day you want to come back to El Camino College to teach after you get your fabulous degrees, be aware this question might be on your interview. What do you think? Why, Mikhail? Why?
Because that's in the second quadrant.
Yes. What's wrong with being in the second quadrant? That's right. Both of you answered correctly. That's right, Mikhail, Cortland. Exactly. It's outside the range. It's outside the range. Okay, you're going to see a lot of such questions about sine, cosine, arcsine, arccosine on the quizzes. Is to clarify. Okay, so you will see firsthand that why these will not be true. Because like I just said, arcsine, all these inverse functions, okay, arcsine, arccosine, arctangent, arcotangent, so on and so forth. Their input, okay, so let me put in a summary. Okay, let me put in the summary. I want to keep it simple, okay? I want to keep it simple a bit. And this is just one column, okay? Arcsine, arccosine, arctan, arccotangent, okay? All of these functions, okay? Their input are ratio, the output are angles. We all understand that, okay? I just didn't include those arcsecant, those, and these angles must be unique. Not only unique, in the range. And this ratio must be in domain. Okay, whatever their domain is. Sine, cosine, their domain is from -1 to +1. And the domain for arctangent is all real numbers. Their output must be one and only. Do you follow me? Because they're one-to-one function. One-to-one function means what? For one input, there's exactly one output. Vice versa. Vice versa. You see, if you think about these words and these implications, right? They're completely consistent. They're completely consistent. They're completely consistent. Okay, so we have covered this episode for this last episode in my plan. Of course, I'm always ready to do a bit more if you guys want to do that. But I think you should have enough tools to work with these. And tomorrow we're going to be working on composition of functions. Okay, which is related to the kind of question you will see on trick 7A. Okay, I'll just give you some heads up. Okay, I will give you some heads up. But you will have homework. You have some new, some additional homework, and I'll be in my office hours, and all of you are welcome to come. And what else? And there will be another quiz. There will be another quiz this week. Maybe I will give you 2 more quizzes, right? We're so happy working these things, and why not? Anyway, you think you had a good time? Did you have a good time in my class? All right, I'll see you guys tomorrow. Great job, very good job. Okay, wonderful, wonderful. I'm very, very pleased. Okay, all right, I will see you guys in office.